Good morning or good afternoon. I hope you're doing well. It's Carl speaking. Alright, so continuing on from part 1 of practical 2, today we're going to be doing part 2, which is to determine the cutoffs and differentiate between applicants. And we need to assume a single predictor, so we're only going to be working with the English test as our predictor, not the others. However, in the exam we might be asked to work with others, other variables, but it'll come down to the same thing. Alright, so let's get started. Question 11. Calculate the SEE, or the standard error of estimate, for a prediction model using the English test as the only predictor. Use two approaches. A. Calculate the standard deviation of the residuals, and B. by using the SEE formula. So, as you can see here, we have the summary output of our multiple regression or our linear regression. Just to refresh your memory, we go to data, we say data analysis, we choose regression, make sure that the y range is our dependent or our criterion variable, the one that is to be influenced, and that our x range in this case is English, as we'll be using that as the only predictor. We want to make sure that labels is ticked, as we're using the whole column from English downwards. We want to make sure that the output range is to our satisfaction, and we also want to make sure that residuals is ticked, as we'll be needing those to do the calculations. So our first step is very straightforward. We make use of, or we calculate the standard deviation of the residuals. To do this, we make use of the formula we did earlier on with the descriptive statistics, which is equals STDEV dot P and then the delta series, in this case being our residuals that Excel has so kindly put out for us. Alright, you'll see it gets a value of approximately 12.19332. Then we go over to option B, or the second option that we have to do, which is to apply the formula. So here we see that the standard error of estimate is equals to the standard deviation of y, which is always your dependent or your criterion variable, times the square root of 1 minus rxy squared. Alright, so where do we get these values? The standard deviation of y in this case being performance, is simply what we had earlier on at the descriptive statistics. Then we have rxy squared, which we can find here, r squared in our regression statistics summary outputs. And then finally we can actually do the formula when we apply it. We see that we want to take this one and we want to times that with the square root sqrt of 1 minus this one here. Alright, so just to repeat, we have 184, which is this one, standard deviation of y times the square root of 1 minus multiple r squared. Alright, and this again you will see that it gives you the exact same as you have up here, which is in my case 12.19332. This concludes question 11. Question 12. Calculate the 95% confidence interval for Franken, Ayer, and Blacker or Blasher, and interpret. What are the implications for the cutoff score and score differences? Alright, so what we do here, we see a confidence interval of 95%, and as we know, this means that it is the standard error of estimate times 1.96. I'm not going to go into too much detail as to how we got to this value. As you'll recall from Mr. van der Bank's classes, he does explain it. Alright, and this gives us a value of 23.899. So basically the confidence interval, we see that the person's score can either go up by this amount or it can go down. So for English we see that Franken had a lower confidence interval of 119.63 and then an upper interval of 167.43. You see Ayer has 133, 181. Blasher or Blacker has 125 and 173. Alright, so I feel I might have been a little bit hasty. So let me just take it one step back and just explain how we got to these amounts here. So when we're looking at the confidence interval, specifically referring to the 95% confidence interval, we see that it has a value of 23.899. But this is specifically relevant only to English as a predictor of performance. In other words, in order to determine our brackets, we make use of the person's predicted performance in terms of the English subscale. See this that we calculated here earlier. So we make use of these three values for Franken, Ayer, and Blasher or Blacker distinctively, and we see that once we put those values in AC3, AC4 and AC5 in my case, minus and plus the 95% confidence interval, we get a nice bracket ordering here. Alright, so now that for question 12, now that we have calculated all these values, we need to be able to interpret them and then mention what happens now in terms of our selection, because we want to make use of 150 cutoff score. But clearly we can see that all of our candidates, Franken, Eyre and Blasher, have the potential to score far beyond 150, but also far below 150. And this makes it difficult to prove a case to use only English as our predictor, in that we cannot confidently say which one of these candidates would be able to perform better, considering all of their intervals both go above and below our cutoff score. So for this purposes, I thought maybe to explain it a little bit easier, I drew up this, just a little bit more of a graphic representation. If we look here at the top graph, we see that this is just a visual representation of the material we have here. And just to see for ourselves, you see Franken has a gap or has a bracket from here to here, Eyre from 130 more or less to 180, and Blasher from 120 to approximately 175. So the top thing we made use of only English to see, and we see that their spreads are quite far beyond each other. They do overlap, but it is very difficult to discern between the two. However, in the bottom square, you will see it looks slightly different. What I did was here is I made use of the predicted performance using all of the predictors. So in other words, we wanted to see how would the person score on English, memory, and agreeableness. In other words, all of the predictors impact on performance. And then taking the same thing with the standard error of estimation, running through our formula, we got to a value of 21.43. So you see here with English it's 23.8, and then when we use all of them for agreeableness, memory, and English, it's a standard error of estimate of 21.43. Alright, so do you see the difference in the graph here? We see that the difference between Franken and Eyre are almost non-existent when we consider the other measures as well. And we see that Blasher is still consistently falling behind the other two. So again, as with the measures that we are using at the moment, it would be impossible to discern between the two candidates, and thus ultimately we can say that either of the two would be a suitable hire given the measuring instruments that we're using. This concludes part 2 of Practical 2. Just a short summary: assuming a single predictor of English test, we calculate the SEE using the standard deviation of the residuals as we determine it here when we got it from our output within Excel, and then after this we went ahead and did it by using the formula that is provided here. We put in all the relevant values and we saw that the two values were identical. This indicates that there are just two ways of doing it. You're more than welcome to take the way that you prefer, unless it's specified in the exam otherwise. Alright, and then after that we looked at question 12, which is where we calculated the 95% confidence interval, which is this 1.96, and we were able to add and subtract it to determine the lower and upper confidence intervals. However, they wanted us to interpret it and also asked us what the implications are for the cutoff score and score differences, at which point I showed you these two tables, just trying to show you the difference if we were to use all of our predictors and only using English. We see that English would be able to differentiate a little bit between our candidates, but it would be neglectful not to include the others as they also share part of the greater picture. And we concluded that it would be a good hire for either Franken or Eyre, as it is impossible to distinguish between the two candidates given the measures that we are using. Alright, and this concludes Practical 2, Part 2.